Hi, welcome back to the Liam Scheff Show on UCY TV and Truth Frequency Radio. Get naked because we're going to talk about outer space. Find somebody to cuddle with, get the cocoa butter, and get started. I'm writing. I don't have time to do a show. I'm going to give you two interviews from a few years ago that you've never heard. You've never heard these guys. And look, I'll be honest, they're low-key. They're not going to come on and tell you about, Dick Cheney, King of the Mole Men, and non-monogamy for everybody. They're talking about outer space. Outer space. They're talking about outer space. They're talking about the problems with Big Bang Theory. They're going to tell you that we're all connected, that stars are electromagnetic anodes, collecting points in space, that they're heated from the outside. That's why they're much hotter above the surface than beneath it. Now, I know what I just said. Believe me, I wrote about it in Chapter 9 of my fantastic book, Official Stories, available on Amazon.com and Kindle, wherever fine Amazon.com books are putting out retail bookstores near you. Let's first start with an interview with David Drew. I'll introduce him in the segment, so I won't do it right now. We talk about how space works and some of the problems with the guy who invented it. Yeah, I know. It was a priest. They do nothing right. Let's just jump in, and again, it's a low-key interview. Hang in there for the information. We're going to follow that with an interview with Wal Thornhill, who's just brilliant. And David's brilliant too, but even David would say that Wal has figured some things out, about outer space, about how stars form. And why does this matter? Maybe it doesn't, maybe it does. It just means that another science, astronomy, is completely wrong. Stars are not nuclear bombs in space. They're not nuclear furnaces going on and on. We make mistakes by thinking that we understand space by what we do here on planet Earth. It's electromagnetic, which means that we're all connected, because we're electromagnetic. That's why putting all these cell phone towers and all the things that scramble our circuits everywhere is not the best idea. Now, I will be back with a new show. Next week, we will be talking a lot about sex and 50 Shades of Super Gay. We're going to talk about why 50 Shades of Grey is essentially some sort of psychotic inversion of Christian parable, even with the characters named Jose, like Joseph, Christian, Anna, just, a very traditional European name, and a couple others who just pop out of like, okay, you're telling us Bible stories, with S&M. But that's next time. Let's tune in and think about electric space. I'm talking today with David Drew. He is the manager and author of all the material you'll find at plasmacosmology.net. David's an independent researcher. He's accumulated a great deal of wonderful information that you can find on his site. David, what can you tell me? Why do you guys give such a hard time to the poor old Big Bang? What's wrong with Big Bang Theory?
Well, the Big Bang, it's a very speculative hypothesis, and yet it's talked about very often in mainstream circles as if it was somehow proven beyond reasonable doubt. And yet it relies on so many hypothetical entities and so many magical scenarios. Ironically, it started out as a little religious dogma. A guy who promoted it initially, George Abbey Lemaitre, was a high-ranking Catholic priest. And it was his intention to reconcile science and religion.
Define the Big Bang for us. What is Big Bang Theory?
Well, the Big Bang, to sum up, as Terry Pratchett once famously said, in the beginning there was nothing, which exploded. I think that encapsulates the Big Bang beautifully. A lot of people say it wasn't an explosion, it was an expansion. According to the Big Bang, there was a point with zero volume and yet infinite mass, and this suddenly expanded or exploded, whichever term you prefer to use, to create the universe that we perceive to some limited extent today.
The Big Bang Theory is supposed to work on the idea of Newtonian gravity.
Newtonian gravity, yeah, again, which is related to mass. But even if you accept the relationship between gravity, which is that can only be described mathematically, and mass, which also remains hypothetical, there is still a massive shortfall of mass in what we can observe, and that requires the invention of more magical entities, hypothetical entities like dark matter, and also dark energy. And according to conventional wisdom, these make up at least 90% of the known universe. Well, Jim Peebles of Princeton University, I think he put it very nicely when he said, it is an embarrassment that the dominant forms of matter in the universe remain hypothetical.
Let's talk a little bit about dark matter. You're saying that dark matter doesn't exist?
It's required to balance the equations. I think that if you factor in plasma and electromagnetism and you look at the universe the way it is, i.e. its filamentary structure, there is no requirement for dark matter or dark energy. They're only required in a gravitational universe. We say that gravity is a relatively weak force. Well, it's a very weak force compared with electromagnetism, because it's something like 10 to the power of 39 times weaker than electromagnetism. That's 10 with 39 zeros after it, which is a huge difference.
I still don't quite get why you guys are so hard on the Big Bang. The Big Bang Theory says, sure, it's a little stagey, it's a little bit like Genesis, isn't it? First there was nothing, and then there was everything. So maybe they were hearkening back. You said that a priest, Georges Lemaitre, invented it. So maybe there's a problem there. Maybe it's not the most scientific theory I ever heard. But surely it's got something going for it. I mean, first there was everything, and they must have had a reason for saying, they must have some rationale.
To be brutally honest, I don't think they have. I think that they're clutching at straws, and I think it reflects something about the human nature, the human mentality, that we need a beginning and an end. You know, when we're brought up as children, most stories start once upon a time, and then they lived happily ever after. I mean, there's a whiff of that about the Big Bang. It's as if it's fulfilling some kind of human need. The weak evidence in support of the Big Bang is not so much evidence as interpretations of data. It really is very, very tenuous.
They talk about a couple things. First, they talked about expansion.
Well, again, the alleged expansion of space is based on an interpretation of data. We can measure light, and we can measure the redshift of light, and the redshift of light may indicate that certain bodies, certain stars, galaxies are moving away from us.
The idea is that things are further away, they're more red. If they're closer, they're more blue. But you're saying that's not necessarily true. Has it ever been
contradicted? If they're moving away or they're moving to us, they can be shifted into the red or the blue, yes, the spectrum of the light.
Has redshift ever been contradicted in any study or experiment or observation?
In numerous studies, indeed. A leading pioneer in this field is a chap by the name of Holton Arp. He's an American who had to go to and work at the Max Planck Institute in Germany because his telescope time was taken off him in America, and his work was being suppressed basically because his ideas contradicted the prevailing dogma.
The current view, the Newtonian view of the universe is all held together by gravity, which you said is 10 to 30, the 39th power weaker than electromagnetism. That's an incredible number. That's what, a trillion, I think they say.
Many trillions, yes.
Yeah. So gravity is 10 to the 39th power weaker than electromagnetism, and yet there are all these objects in space. They move around. Things explode. They emit currents of light and heat and what looks like electricity. The Big Bang model didn't predict what we see in outer space. It didn't predict these massive lines of essentially power cords streaming with ionized gas. It didn't predict.
That's a fine analogy. Yes, power cords.
It didn't predict quasars. It didn't predict things emitting radio signals at hundreds and thousands of times per second. It didn't predict all of this.
I can't think of anything that it predicted. There isn't really anything.
So the Big Bang modelers had to come up with essentially an infinite source of energy, and we all know that because we've all watched Star Trek. What is that infinite source of energy in Big Bang Theory?
First of all, you mentioned that the power cord. I like that analogy. Space was meant to be empty. It was meant to be an almost near-perfect vacuum. Turns out that it's not empty. It's full of plasma and electromagnetism. Electricity forms magnetic fields. Those magnetic fields pinch the electricity to form filamentary structures, power cords. That's what we see. We see a filamentary universe. That is the structure and pattern of the universe. In gravitational cosmology, it can't account for these filamentary structures. At the center of a lot of galaxies, what we do see, without any shadow of doubt, is intensely energetic and compact activity. The mainstream refers to these areas as black holes. We don't know what these areas, what's happening in these areas, but the mainstream tries to explain this intense energetic activity in purely gravitational terms, and it refers to them as black holes. The point with zero volume and infinite mass. Does nature really make points? Does it really make something with zero volume and infinite mass? Is that possible, or is that a mere mathematical abstraction?
Are you saying that black holes aren't real?
Well, black holes, like so much mainstream astronomy and cosmology, is passed into science fiction, and it's kind of a strange relationship between science and science fiction. These ideas start as tenuous scientific hypotheses, and then the writers, the science fiction guys, run with these ideas, and then these fanciful ideas are kind of fed back into science, and science fiction becomes the reality. I mean, that's what's happened. And add to this the mathematicians, astronomy and cosmology are fields that are now dominated by mathematicians, not scientists. And it's as if the mathematicians and the science fiction writers are trying to outdo each other.
One of the odd things about galaxies as they spin is that the outer parts don't seem to lose speed against the inner parts. If it were gravity, you'd expect that they'd start to lag behind and pull apart. How does plasma cosmology look at that?
Again, gravitational models struggle to account for these shapes, particularly the spiral galaxies. The spiral patterns are expected and predicted from an electromagnetic perspective. I mean, that's what electricity and magnetism does. It very often produces spiral patterns. And again, because of the immense power of electromagnetism, it can hold these structures together, and it can get all the different parts to spin simultaneously.
One of the things I found in reading was that black holes, or the concept of black holes, again, because they're invisible, they can't be seen, they have to be inferred or maybe implied, was that they have no standard size. They can be I've read that they can maybe be as small as atoms, tiny,
yeah.
or as big as supercluster galaxies. Stephen Hawking proposed in one of his books that the universe was in fact entirely created of a foam of sub-universes that were embedded in electron-sized or atom-sized, connected by wormholes to everything. This seems to me to be a fanciful idea, but Stephen Hawking is not a respected astronomer, cosmologist, physicist.
Well, Stephen Hawking, brilliant guy, but he's very much on the mathematical side. And yet again, we see the competition between the mathematicians and the science fiction writers to come up with more and more bizarre and challenging ideas, which are fun, but not necessarily based on anything real. We touched on gravity a number of times. As I mentioned, gravity, we don't understand the mechanism behind gravity. It's described mathematically. And what so many people have attempted to do, what Einstein basically did, was to say that gravity was the fourth dimension. He factored in time as the fourth dimension, and that gravity is a product of this fourth dimension. And as soon as you allow for this mathematical fourth dimension, well, then you basically open the door to numerous mathematical dimensions, and hence you end up with things like string theory and foam and all these weird and wonderful ideas.
Wait a second, David. Are you saying that Albert Einstein, might not have been correct?
Well, Einstein, again, was a very modest guy. He wasn't satisfied with his own ideas. He admitted that they were speculative and mathematical. He in fact, didn't believe in black holes. But what happened, he was trying his best to try and work out what was going on. And in many ways, he obviously advanced science. He was a brilliant mind. But like I say, he was modest. He wasn't happy with his own ideas. But so many other people ran irresponsibly with his ideas, and they just took off and went out of his control. I mean, as Einstein famously said, to the degree that reality is based on mathematics, then reality is not real. He said that, since the mathematicians have invaded the theory of relativity, I do not understand it myself anymore. More pertinently, he also said, to the extent that the laws of mathematics refer to reality, they are not true. And to the extent that they are true, they do not refer to reality. That's Einstein himself summing up the mathematical approach.
when you're talking critically of math, you're not saying you hate math, but you're saying that math is taking the place of what we would think of as science or observation.
Indeed, we've got things the wrong way round. It's happened in a number of areas of life. We talked about mathematical models earlier. I mean, look at all the crazy shenanigans going on now in the financial world. So many of them, so many financial problems have been created by crazy mathematical models which weren't based on reality.
So if I understand this, Newtonian cosmology says the world is ruled by gravity, a very weak force. Plasma cosmology says it's ruled by electromagnetism, an immensely strong force. Newtonian cosmology struggles to predict anything in outer space. Electromagnetic or plasma cosmology predicts the shapes of galaxies and the power cord or filamentary shape of structures in outer space.
Sherlock Holmes, being a cosmologist, he might have said, "It's filamentary, my dear Watson."
Well, on that note, David Drew is the manager and author of
PlasmaCosmology.net.
He has a YouTube channel, SoupDragon42. I recommend checking both out. Great introduction to the philosophy and history of plasma cosmology and some of the problems with our current Newtonian system. We will be back with more people talking about plasma cosmology. If you want to come and argue for the Big Bang Theory, I'd be interested in hearing arguments for that too. David, thanks very, very much for your time.
Thank you. I enjoyed it.
And that was David Drew of PlasmaCosmology.net, I believe. Let's jump into the interview with Wal Thornhill. Let's talk about stars. No, they're not nuclear bombs in space. They're something much, much more interesting. Wal is going to talk about plasma physics. Plasma are electrified particles. They're all over the place. Our cells are electrical. The fractal shapes of which we are formed, of which everything participates, is electrical. We are connected. Somehow mainstream science doesn't want you to know this. We're going to talk about it now. My very special guest today is Wal Thornhill. Wal trained in physics and electronics at university before going to work for IBM. Wal specializes in the field of plasma cosmology. Wal is a founding member of the Thunderbolts Project, which you can find on the web at thunderbolts.info. This is a group project devoted to understanding the actual nature of the universe, which is, they contend, electrical, not gravity-based. Today we're talking about stars. Wal Thornhill and other plasma cosmologists contend that stars are not gravity-based nuclear furnaces, but are in fact electrical. As electrical bodies, they fission, they expel material, and that material, contends Thornhill and others, becomes gas giants and small rocky planets. It's a fascinating model of the universe, so let's get into it. We're supposed to think stars are nuclear explosions in space. What's the problem with that?
Well, the problem is that it's an accident of history. It was born out of an era when the mathematical theories of space and what was going on in space sort of began to dominate, rather than any notion that there may be alternatives. Sir Arthur Eddington wrote The Internal Constitution of Stars. It was a seminal work. It was the first time that anyone had been able to put forward a coherent picture of how you might generate energy inside the sun to form a ball the size of the sun, radiating energy the way we see. But in order to do that, he had to make some assumptions, some of which we are unable to test in the laboratory. For instance, the nuclear reactions at the centre of the sun have never been reproduced in the laboratory because we can't recreate the conditions. And also there is the very strange suggestion that within the sun, the X-rays that are emitted from the nuclear explosion, if you like, at the centre of the sun, have to be watered down, if you like, until they become non-lethal heat and light at the photosphere. And to do that, he introduced the idea that the X-rays go through a radiation zone inside the sun. Now, there's no physical body we know that transfers energy internally by radiation. It's always by convection or conduction. So there are some pretty wild guesses. Nonetheless, it was the first time that anyone had been able to put forward a coherent story as to how the sun could shine for billions of years and maintain its size and its light output for that period of time.
Let me get a couple things straight. The photosphere is what in terms of the sun?
That's the shining ball that we see in the sky. That's where the light comes from.
There's an area right above the sun, essentially in the air. What do we call that?
There's the chromosphere just above that. When you see it during a total eclipse, you see a red kind of a glow just above the photosphere, and that's called the chromosphere, the chroma meaning colour. And then above that is the corona, which you can see during a total eclipse, which is very faint, but it's a kind of bluish-white light which extends at some distance from the sun.
So the trouble that I suppose astronomers have had was that in the body of the sun, even on the surface, the chromosphere is cooler by how much? Then it's actually a lot hotter outside of the sun in the chromosphere, I think is what you just called it.
Well, the temperature rises up into the tens of thousands of degrees in the chromosphere, and then into the millions of degrees in the corona. So the difference between the photosphere and the centre of the sun and the corona is of the order of millions of degrees.
That's astounding. So they're saying that this is a nuclear explosion. The hottest part is in the middle. The surface of the sun is 5,000 or 6,000 degrees, and as you get away from the sun, it's millions of degrees. Does standard astronomy have any explanation for this?
Well, they've been struggling with it because to have such a system, somehow energy has got to get from the centre of the sun to the exterior of the sun and bypass the photosphere. And so there's been all sorts of clever suggestions, like magnetic fields reconnecting, and which is actually a non-physical thing anyway. It's the kind of desperate idea that you cook up when you can't think of anything else.
One of the other contradictions with a regular sun model is that, again, it seems to be cooler on the inside, and I say that because of these great pictures of sunspots that have come out in probably the last 5 or 10 years. Can you tell me a little bit about those?
Yes, if the sun is being powered from the outside, then if the glowing shell, the plasma discharge shell that we call the photosphere, is parted magnetically, which is what happens with a sunspot, then you can see beneath that glowing layer to what's inside the sun, if you like. It's like the parting in the clouds. You can see deeper down into the atmosphere. And when we do that, we find that it's cooler beneath those shining clouds. And this is what we would expect if the sun is being powered externally instead of internally.
When you look at a sunspot, when I was a kid, nobody knew what they were. As telescopes got better, you could see that there were these wonderful filamentary shapes reaching in and covering this surface, and the surface is black.
Yes.
Not glowing red, but black.
That's right. It appears black by contrast with the photosphere, but in actual fact, if you were to be able to see it without the photosphere, it would be glowing red. But, of course, several thousand degrees cooler than the bright photosphere.
So all of this leads in a difficult direction for current astronomy, which is that stars, according to these observations, must be powered from the outside, not the inside.
Yes.
How is this? What are stars then? How is this possible?
In the realm of plasma physics, we have the Nobel Prize winner Hans Alfvén. He looked at the magnetic character of the sun and also the solar wind. He determined that it is actually an electric current that's flowing in the vicinity of the sun. And it seems to flow along magnetic field lines, if you like, in at the poles and out at the equator. And the solar wind is merely a representation of the current flowing from the sun. It's rather like an air ionizer, those small devices where you purify the air and it emits a small current into the air. And if you hold your hand in front of the ionizer, you can feel this breeze blowing against your hand. Well, the sun is the same thing. The current is in what they call dark mode. In other words, it's not glowing, you can't see it, but you can feel it as a wind. The stellar winds are a feature which are very difficult to explain. So that's resulted in a lot of hand-waving about how the wind is boiled off the sun. That's what they say. Yet the fastest wind from the sun comes from the coolest regions on the sun, which is easily explained in plasma terms, but it's not in normal kind of mechanical wind terms.
Oh, cliffhanger. Cliffhanger. We'll be right back. This is Liam Scheff on the Liam Scheff Show, UCY TV and truthfrequencyradio.com. You can find more about the electric universe in my book, Official Stories. See you in a minute. Official stories exist to protect officials. With the opening line as our guide, we're going to pry open the vault of officialdom and see what lies beneath. Drawing on also on information from 10 years of investigative journalism, Liam invites you to join the hunt for the details that lie just beneath the surface of history. In this heavily researched but irreverent book, True, we'll look under the rocks and stones of our culture, from CIA and JFK to 9/11 and Shakespeare, from vaccination to HIV to Big Bang Theory, Darwinism, plate tectonics, and more. Think of it as a corrective textbook to all the tales we were taught in school. We'll ask the questions. Why do we believe what we do? Why do we accept some stories that thank you. Why do we accept some stories as true when the details so obviously contradict the headlines? We're going to find out what's real, what's true, and what's just an official story. Let's read a review. Few explanatory journalists think or write like Liam Scheff, writes Terry Michael, director of the Washington Center for Politics and Journalism. That's too bad, he says. The progressive era's crusade to replace a partisan press, that's somebody with an opinion, with theoretically truth-vetted journalism was noble but misguided. Progressive replaced tainted partisanship with faith-based reliance on oxymoronic social science expertise, and with rulebooks interpreted by unaccountable bureaucrats, culprits who tell those official stories. Their tales are often convenient lies to mask ignorance, fear, and greed, to cover the asses of officials who tell them. But these official versions are used also by objective journalists to cover their own rear ends, to get stories past editors by quoting authorities instead of doing their own bloody research. I added the bloody. Liam Scheff debunks official lies about things like HIV and AIDS, and may I add, parenthetically, Big Bang, Shakespeare, vaccination, CIA, JFK, 9/11, with simple, research-informed language, providing you don't need advanced degrees or keys to temples jealously guarded by the new science and medicine gods, who have replaced priests and princes as enforcers of truth. Scheff writes with revealing and entertaining satire. His is a work I'll recommend to the future political reporters I try to teach about the increased politicizing and corruption of science and medicine. Again, Terry Michael, director of the Washington Center for Politics and Journalism. Thank you, Terry, and thank you, audience. Let's get back to the show and go pick up Official Stories. It's on Kindle and paperback. Kindle's going to be delivered right there into your brain. Let's get back to the show. Hi, welcome back to the Liam Scheff Show on UCY TV and Truth Frequency Radio. Next week, we're going to have a show and we're going to demolish 50 Shades of absolute bullshit. 50 Shades of Grey
is going
to be the most explicit show that I've ever done. And I hope to set a new high and or low watermark for what will be happening and what I'll be able to talk about. Yes, we're going to talk about sex, vajigis, boobles, and pum-pums. But not this time. This time we're talking about outer space. Walt Thornhill of holoscience.com and the Thunderbolts Project is a plasma physicist, plasma physics researcher, writer, and I think great thinker. I truly mean that. I think he's a great thinker. Fascinating, interesting, articulate, not given to incredibly wild speculation, not a proponent of things that you really can't demonstrate, but he's telling us that space is this electromagnetic, fascinating star forge, and that we are, the little products that bubble up on these planets that are probably hunked and spewed out of brown dwarf stars. Well, we'll get to that. Oh, spoiler alert. Okay, here we go. This is an interview from a few years ago, and some of the interview made it into my book, Official Stories. So, without further ado, let's get back to Walt Thornhill. We're talking about the gases coming off of stars. Now, the mainstream wants to say that there's some kind of nuclear furnace pushing neutrinos out of the star. But no, this is an electromagnetic system. We're going to talk about that now. They're fast, what you're calling breezes, that are made of what, electrons or of particles of atoms?
It's a plasma, generally a mixture of electrons and protons. In other words, the constituents of hydrogen atoms. But the electrons have been split off the nucleus, and so you end up with positive and negative charges. They respond to the electromagnetic forces much more strongly than they do to gravity. So to accelerate the solar wind away from the sun, which is what we observe, the wind gets faster the further it gets from the sun, which is in defiance of gravity. But to accelerate the wind requires only a very weak electric field to provide that acceleration. And it's exactly the kind of field we would expect in a glow discharge. It's the kind of thing observed in the laboratory. So all of the features that we see in space surrounding the sun fit the electric model. And Hans Alfvén actually drew circuit diagrams for the sun because the sun obviously wouldn't stay alive unless you provided the electric power. The thing that Alfvén didn't do was to take that further and show where the electric currents flowed within the galaxy, because it is the power lines, if you like, that follow the spiral arms of a galaxy, which have the stars strung out like streetlights along those power lines. It's quite a simple model, and it fits all of the observations. The problem you have is that the standard theory has become so entrenched that it suffers from confirmatory bias. In other words, everything you find, you try and squeeze into that model regardless of how well it fits. A lot of money and time and effort is wasted, unfortunately, today in trying to fit an outdated model to new observations from spacecraft.
There's a wind coming off of stars, and this wind of protons and electrons, what you're describing as the components of hydrogen, they speed up the further away they are from the star. And you're saying that this is a property of a magnetic or an electromagnetic pinch or activity on electrons and protons.
It's more simple than that. In a neon tube, for instance, you see the glow extending along the tube, but near the electrodes there are dark spaces. The glow, if you like, is the kind of glow that a star produces, and there are many red giant stars which produce light just like a neon light. It's the dark spaces, what we have in interstellar space and in intergalactic space. In other words, the current's still flowing there, but it's invisible. Stars are like a focus, like an electrode sitting in a discharge, and they light up in that discharge. It's something that you might have met in high school when you play with the old Geissler tube experiments and so on.
You overestimate our high schools, but go ahead.
Well, I remember it vividly because I had the privilege of being allowed to play with such instruments at school. So maybe this was a kind of a formative moment in my career. It became obvious to me when I read Ralph Jurgen's explanation of the electric model of the star. It just made complete sense to me, and I didn't need any more convincing than those initial arguments. What I've done in following Ralph, since I was waiting for other people to pick it up and then found nobody seemed to be willing to do it, but when I picked it up, I've progressed the model somewhat and fitted it into a broader picture which involves a new cosmology called the electric universe.
Where does the energy from all the stars all the stars you're saying are in a galactic circuit. So you're saying that energy is flowing from star to star. Where's the energy coming from? Or is this just an ongoing circuit, or how would you describe it?
As far as we can see, and when I say see, if radio telescopes are very important in the electric universe because they can detect radio waves and detect their polarization. And the polarization of the radio waves allows you to map the magnetic field directions in space. And once you've done that, it's a given in plasma physics that electric currents will flow along the direction of the ambient magnetic field lines. So in other words, you can begin to trace the circuits in deep space. And we find the galaxies themselves arranged like Catherine wheels. That's the great spiral galaxies. They're arranged like Catherine wheels along intergalactic power lines, if you like, these what are called Birkeland currents. They're like giant twisted pairs of electric currents which flow through space in various places if the density of the matter, the gases and dust in space are sufficient. These pinch down. It's called a magnetic pinch. And in pinching down, they scavenge the matter from surrounding space and squeeze it, heat it, rotate it, and form the stars that we see. But they do that in a particular pattern which we can reproduce in the laboratory, and that pattern is the spiral galaxy. It's an organic picture of the universe, and it's a connected picture. We're not isolated islands in space. Stars are not isolated, they're connected electrically and in other ways, gravitationally. So it gives a completely new way of looking at our place in the universe.
Let me recapitulate that for my own purposes just for a second. You're saying that there are currents that go through space. They occur in pairs, that they attract each other up to a point at which point they repel each other. In other words, they don't merge and become one, but they spin around each other. They travel through space. They pinch in this thing you're calling a Z-pinch, which is a known quality of electromagnetic currents, and you can reproduce this in the lab, and you can see this over and over again, and that these are the very things in space that form galaxies. And it's organic, it's reproducible. Your modeling of stars, then, takes these objects which are in a galactic circuit of flowing electromagnetic energy and are pinched, and then something wild happens.
Ah, yes. Yes, there's one of the urban myths in astronomy is that the planets are formed from the leftovers after a star is born. In other words, from a disk of dust and gas surrounding the star. There is this argument that the concept has been proven because when you look at nearby stars, we can also now see some of the planets that orbit these stars. We often find a disk of dust and gas as well. And the idea is that that disk is the leftovers from the gravitational process of collapse, when a cloud is supposed to have collapsed and rotated and formed a central star and planets surrounding it from the leftovers.
So the gravitational model of the formation of the solar system is that there's a rotating clump, and somehow out of that rotating clump a sun forms, but that somehow separates from all the planets, and the gassy planets move to the outside, and the rocky planets stay on the inside. Has anybody ever been able to make this work in any kind of simulation?
Well, you'll notice you use the word somehow several times, and that's the operative word in modern astronomy, is somehow these things happened. There is no real understanding of the formation of a planetary system. And also in our own solar system, one astronomer said to me that you need a different theory for every planet, because the planets, when you look at them, they're so different. You know, their axial rotations are all over the place, their speed of rotations are different, their apparent compositions are different. There's very little about them that you could say makes them any kind of evolutionary family of objects. The electric universe has a much simpler view, and that is that when a star is forming, if there is any disturbance to the star as it collapses and rotates, then if a part of the core of the star is offset from the centre by a small degree, there is an electrical effect which takes place, which tends to repel like repels like. This is one of the differences between electricity and gravity. Gravity always attracts, but electricity can repel. And you can get a situation where part of the core of a star will actually be ejected, or some of the matter will be ejected from the star as it's forming. And it can happen to objects the size of gas giants as well, Jupiters and Saturns and so on. And the fact that they have so many satellites is indicative of the fact that they have ejected material from their interior during their lifetime. In fact, Saturn, with its ring, the ring is ephemeral. It cannot have been there for more than tens or hundreds of thousands of years. It suggests that Saturn was probably the most recent object in the solar system to give birth. So you have this idea that you can eject matter, forming rings of dust and gas, and also planets around a larger object like a star or a gas giant. So it is a more biological view of how things work in the universe.
What you're saying is that if there's a disturbance or something, you said somehow off-center, and there's a difference in charge, then a repelling action happens inside of very, very large bodies that are in the galactic circuit, and that off-center bit will repel out of the major body and I guess let it go back to equilibrium, and then there will be two objects.
Yes.
And one, I guess, will be much smaller than the other.
Yes. Generally that's the case. It's interesting that when we began to actually detect planets around nearby stars, the ones that are found most easily, of course, are the very large ones. But astronomers were amazed to find that these large planets they call them hot Jupiters, because they were found extremely close to the central star, which was a complete puzzle to them, because it was thought that gas giants like Jupiter and Saturn can only be formed in the outer reaches of a stellar planetary system where the lighter gases and so on are not blown away by the central star, because we know that Jupiter and Saturn have a considerable amount of hydrogen and helium. The lighter gases, which should, according to standard theory, be blown away when the new star is born. So here we have these huge Jupiters and Saturns, if you like, orbiting their central star, some with periods measured in days. In other words, they're whipping around their star very close indeed. Giving birth electrically explains that, or can explain that, but just the other day there was a report that they found that some of these hot Jupiters are actually orbiting in the wrong direction. They're going around in the reverse direction. That suggests also another aspect of the electric universe, and that is electric capture. When stars are born, they're born in groups. Once the magnetic pinch subsides, they tend to, in the words of Tony Peratt, scatter like buckshot. And in that process, there is a high probability of capture of one body by another. And when that happens, of course, you can have orbits in any direction with any orbital tilts, and they can be retrograde. And that seems that kind of thing must have occurred as well.
Stars can fission. They can give birth to secondary stars, hot Jupiters. What about the small rocky planets? Where do we come from in this model?
In this model, the rocky planets are formed from red dwarf stars, which are rather like Jupiter or a Saturn, on their own, travelling on their own through the galaxy instead of being associated with a bright star. If a red dwarf meets a bright star and is captured by it, it will transform from a star into a gas giant satellite or planet around that star. And when you look at our gas giants, they're also different. They're also far from the central star that I would suggest that they were captured rather than having been born with the sun.
And so where do we come from? Where does Earth come from? If Jupiter and Saturn were captured, where do we little rocky planets come from?
Well, this is where you get into an area that sounds more science fiction than science fiction, but we have good evidence that the Earth was born from one of the gas giants in our solar system when that gas giant was an independent brown dwarf and before it was captured by the sun.
Let me see if what you're saying is that the Earth and maybe some of the other little rocky planets belonged to either Jupiter or Saturn, and that red dwarf, because you're saying that would have been a red dwarf outside of our sun's influence, was captured, but once it was captured inside of that larger, our sun's magnetic field, it diminishes as a star and becomes a gas giant, and then if I'm following what you're saying, these little planets then can get ripped out of their orbits and fall and go around the larger star in the system.
Yes, one of the interesting aspects of the electric universe is this question of where does life originate. And astronomers in recent years have just begun to twig to an idea that I proposed a decade or more ago, and that is that the most hospitable place in the universe for life to form is within the electrical sheath of a brown dwarf star, where you have a relatively cool star, and because it's cool and it's low voltage, I suppose you could say, the sheath that surrounds it, the glowing sheath, is actually quite huge, and the satellites orbit within that sheath. And any object that's orbiting within a glowing sphere receives the same amount of energy on every square inch of its surface, which means that there are no seasons. You don't have to worry about axial tilts, rotation rates, orbital tilts, or anything like that. Everybody orbiting within that glowing sheath will receive a benign radiation, the same radiation at the poles as at the equator. It seems the Earth was in such a state at one time. We know that there has been coal found at Antarctica, and animals were living happily in the Arctic Circle in the recent past of the Earth, which gives some idea that the history of the Earth has been quite dynamic in the recent times. But as I say, the interesting aspect of this is the search for extraterrestrial intelligence, because we are looking for radio signals from life forms in space. But if life forms are formed preferentially inside these plasma sheaths, as they're called, then radio waves will not penetrate those sheaths. So we're wasting our time. It's only rare instances like our own where we have been torn from our birthplace and yet survived, found ourselves in a situation, a rather precarious one I might add, where we orbit just far enough from a bright star that we can survive and actually witness the universe in all its glory. Otherwise, we would not know that the universe exists. We would be inside a mere glowing shell with no idea of the enormity of the universe outside.
I want to throw in one idea into this, which is dinosaurs. Dinosaurs are these massive animals, and real paleontologists and biologists who try to reconstruct their movement always come up against the same problem, which is their existence. Given our gravity and given what we know about gravity on planet Earth, they couldn't have moved. They certainly couldn't have flown. Most of them couldn't have held their heads up.
Yes.
If the Earth were rotating a smaller star, do you think that would have changed the situation in terms of gravity and the life the Earth could support?
Yes, I consider that a crucial piece of evidence in favour of the electrical model of gravity, because it's generally regarded that gravity is a function of mass, so the mass of a body determines its gravity. But then there is this confusion, quite interesting confusion in the minds of experts between mass and matter. In other words, mass is usually confused with the amount of matter. But we know that, for instance, in the particle accelerators, you can accelerate subatomic particles up to close to the speed of light, and their mass increases enormously. Now, it's still a proton or an electron or whatever it is you're accelerating. However, its mass is much greater than normal. The electric universe suggests that all subatomic particles can change their mass in response to their electrical environment. And of course, the Earth's electrical environment as a satellite of a brown dwarf star would have been quite different to what it is with our present sun. And it seems that the electrical stress was much less, so that the apparent mass of the Earth would have been a fraction of what it is now, with the result that the atmosphere would have been more extensive. Large animals could have survived. The flora and fauna, they call it megaflora and megafauna, had an environment in which it could thrive. And all that changed suddenly, so that what killed the dinosaurs was a drastic change in the Earth's environment.
Can you foresee a way to take these electrical pathways in the universe, these Birkeland currents, and harnessing any of them for our use?
Not directly. Actually, the electric universe deals with both particle physics as well as, that's at the smaller scale, as well as the cosmology of the grander scale in the universe. At the smaller scale, when you look at particle physics and quantum theory, another thing that's not recognized is that quantum theory is theory without an explanation. There is no physical explanation for why quantum effects occur. And this is shown by reports which talk about the spooky behavior of particles in the quantum level. Now, the electric universe doesn't like these ideas without any explanation. In trying to understand gravity, I came to the conclusion that it required that all subatomic particles are made of smaller charged particles which are in orbit, and they're a resonant system, so that all of the stable particles that make up the matter that we see and touch is in the form of resonant electric charge. Now, this gives the idea that you can actually achieve nuclear reactions at room temperature using resonant catalysts. Now, there's already a company in the US in New Jersey called Blacklight Power which seem to have stumbled upon this, and they're using heavy elements like iron. An iron atom has a huge number of resonances because it is a heavy atom, and they've managed to tap into that resonance and use it as a catalyst to extract energy from the hydrogen atom, which has not been achievable before. So I think when we begin to understand what quantum mechanics really means in terms of real particles, then a whole new avenue for extracting energy from atoms will be available. And the funny thing is that it seems biological systems have known how to do this right from the get-go. A famous French scientist, Louis Kervran, has shown that biological systems are able to transmute elements in order to tap into nuclear type energy.
Well, that's beyond interesting and beyond exciting, and I think I'll have to come back. I'll leave that as a tease. Wal Thornhill's writing, his excellent essays, his wonderful articles can be found on holoscience.com, HOLO science.com. While you work with the Thunderbolts project, what do you guys have coming up, and what can people look for?
We are producing a series of 3 DVDs. We have the first one is available, the second one should be out in a couple of months, and the third one is planned. They will cover all of the aspects, including the prehistoric recording of what was happening in the Earth's heavens, which gives us an insight into the recent history of the solar system, and it will tie that in with the electrical model of the universe.
All this can be found on thunderbolts.info. Wal, I want to thank you for your time. I think your work is some of the most fascinating I've ever come across. I don't know why NASA can't swallow some humble pie and walk over to you guys, and I hope that soon that they do. I wish you great success in your ventures.
Thanks, Liam.
You bet. This is Liam Scheff. You've been listening to Challenging Scientism. Please look up Wal Thornhill's work at his website. Go to thunderbolts.info. You can look me up at liamscheff.com. See you next time. Challenging Science? What the bloody hell is that? No, this is the Liam Scheff Show. And yeah, that was me a few years ago. More than a few. That was 5 years ago. 5 years ago. Or maybe even more. Maybe 6. Interview with Wal Thornhill of Thunderbolts Project, holoscience.com. Great stuff to read at those sites. Fascinating stuff. And I'm not talking about Nibiru's coming to get you. Nibiru's coming to get us. Oh, we don't know what to do. No, I'm not. I'm talking about reproducible plasma experiments that you can do in laboratories that people do all over. You can look up plasma experiments online and see people making what looks like stars and coronas and auroras and the rings of Saturn, all by taking these charged metal bodies called terrellas and shooting a plasma gun, which is, again, is a charged particle, something with an electron imbalance. And it looks like what happens in outer space, because it is what happens in outer space. The Big Bang did not happen. It was invented by a priest in the 1920s. We live in the Victorian age, everybody. We live in the late Victorian age. That's when we live. We're still living with the science of Queen Victoria, Georges Lemaitre, the priest who invented all of it. Oh, what are we going to do? You're listening to the Liam Scheff Show on Truth Frequency Radio. and ucy.tv. You can find me on my webpage, liamscheff.com, more often on the FBI social network, where I throw Chinese darts at the, what are those called? Chinese stars, sorry, at the vaccine police. You can buy my book on Amazon.com, and you can put money into my account through PayPal to keep the research going. My sexy talk coming up next week, and a new novel coming your way as well. Well, we've been listening to material about the electric universe. Let me read you a little bit from my book, Fish Stories, from Chapter 9, Big Electric Bang, all about outer space. We get the gravity-only thing from Isaac Newton. So I give a little history of Isaac Newton. You can't fault Isaac for not knowing about the more powerful force. He lived in the era before electricity. There were no street lights, no blenders, radios, TVs, power stations, transformers, or batteries. Or cell phones, thank God. Talk about a harbinger of the apocalypse, bloody cell phones. I don't think this is what Grandpa Watson intended. He was a spiritualist, after all. Yes, my great-great-grandfather helped invent the telephone. I didn't get any money for it. Isaac, he lost it all in something else. This is all parenthetical. Isaac did not include electricity in his equations because it wasn't part of his world. It is a new phenomenon in human society to be able at will to motivate flowing electrons to do work. We're in a different age, and NASA still hasn't caught up. But some independent scientists have. They're called plasma physicists. The universe is filled with plasma. It is the fourth state of matter after solid, liquid, and gas, but it's first by volume, comprising 99.9999% of the universe. It's a sea of charged particles, carrying electric current into voltages ranging from so low they barely register to so high they burn at millions of degrees. It's a living thing. Plasma looks alive. It forms into thin cell walls in space, millions of light years across. It curls into spinning vortexes, like fiery tornadoes. It glows warmly and forms cocoon-like enclosures. It beams and twists and exerts such a power of attraction that it scavenges all the material around it and superheats it, pinching it down into orbs. You've seen plasma, but don't realize it. The spiraling serpents of light we see in pictures from the Hubble telescope, these are plasma. The glowing filaments emanating from nebulae like Medusa's hair, plasma. And here on Earth, neon lights and the sun-bright lightning swords used in arc welding, and lightning itself, are plasmas, electrically charged particles in a gaseous state. Plasma acts differently depending on its density and level of charge. When the particles are few and dispersed, the plasma runs dark. Increasing the density makes it glow like a neon, and tightly bunched, highly charged particles burst into sun-bright streamers, plasma in arc mode, like lightning and the surface of the sun. That's where we live. It's a plasma